Good morning, students. In this session, we will discuss about the introduction to Turing machine. So, why we are going for Turing machine? Actually, we have discussed about finite automata and pushdown automata in our previous lectures. So, we know that clearly that there are many limitations in finite automata. So, major limitation in finite automata is it has no memory, or we can mention it as a limited amount of memory. Limited amount of memory in the sense it can process only the strings. It cannot remember the previous input or the previous transitions. Okay, it can remember only the current state of the input. And another one major limitation in finite automata is random access is not permitted. So because it will process the string alone, it won't do any operations with that string. Okay, it will just read the input and it will show the user whether the entered input is as per the language or not. That's all. The next thing is pushdown automata. It has limited amount of memory. The memory is in the form of stack. Definitely memory is there in pushdown automata comparing to finite automata. Here the memory is present in the form of stack. So we know that if stack is used as a memory element, we cannot perform the random access because stack works on the principle of first in, last out, or last in, last in, first it will be served. Okay, so these are the major limitation in pushdown automata because we cannot perform the random access. And comparing to finite automata, pushdown automata performs well. We can do some comparison operation in pushdown automata as well. Okay, so when you are coming to the Turing machine. So Turing machine is a device. So as finite automata and pushdown automata are mathematical model, Turing machine is a device that can perform both finite automata and pushdown automata, and it will overcome the limitations of finite automata and pushdown automata. Clearly understand that Turing machine will be related to our real world computer. Okay, so Turing machine was proposed by Alan Turing in 1936. He is a mathematician. He is also mentioned as father of computer science. So he designed the Turing machine. He proposed the Turing machine in 1936. Okay, so this is the picture of the modern Turing machine. So there are some elements present and some components present in Turing machine. So before going into the components of Turing machine, we have to discuss about the difference between the finite automata, pushdown automata, and Turing machine. So the first thing is in processing the string, the finite automata can process the input only from left to right. In pushdown automata, the string processing is done either through first in, first out, or last in, first out. Okay, last in, first out. So this is the logic performed in pushdown automata. And coming from Turing machine, the string can be processed either from left to right or right to left direction. Both the direction string processing is accepted in Turing machine. Okay, and finite automata and pushdown automata, it will not permit the random access, but Turing machine will permit the random access. So this is the definition of all these automata, finite automata and pushdown automata and Turing machine. So I will discuss in detail about the definition of Turing machine in the next lecture. The next thing is extension of abstract machines, that is finite automata. Then extension of NFA with epsilon transition, that is pushdown automata. The extension of finite automata as well as pushdown automata is done in Turing machine. When you are speaking about the memory, memory is limited in pushdown automata and somehow the memory is limited in finite automata. Actually here it is mentioned as it has limited memory, but according to the point of contact, so there is no specific memory in finite automata. Limited memory in the sense it can access it can process only the current state. That's why they have mentioned as limited memory. But comparing to finite automata, push down automata has some limited memory in the point of stack. Turing machine has unlimited memory. Okay, there is no limit for memory in Turing machine. There are when coming to the types of these machines, finite automata has two types, NFA and DFA. Push down automata has two types, that is deterministic push down automata and deterministic non-deterministic push down automata. Same like finite automata and push down automata, Turing machine is also has two types. One is deterministic Turing machine, another one is non-deterministic Turing machine. So when you are coming for multi-tape, so storage of the inputs, the variable which is going to carry the inputs. Okay, you can see here multi-tape finite automata is not possible. Multi-tape push down automata is not possible, but multi-tape Turing machine is possible. Okay, that's why it is Turing machine is called as it is related to the computer. So what are all the problems that can be solved by the computer, that can be solved by the Turing machine? The problem, some theoretical problems that cannot be solved by Turing machine, the same problem cannot be solved by the computer also. Okay, so when coming to the flexibility and performance, finite automata has very low robustness and push down automata has partially robustness, and Turing machine has high degree of robustness. So how we can conclude an automata? In finite automata is accepted by only final state. In push down automata it is accepted by final state and empty stack. In Turing machine we can have the final state in the form of accept state as well as reject state. So either it will halt at accept state or it will halt at reject state. Okay, both the things is possible. If you are giving a wrong input means it will go to reject state. If you are giving wrong input means it will be going to the reject state. If you are giving the right input means it will be going to the acceptance state. Okay. And epsilon moves are possible in finite automata. Epsilon moves are not possible in push down automata as well as in Turing machine. So then coming to the functions of these three comparisons, finite automata acts as a string acceptor as well as the push down automata will be acting as a string acceptor, and it can perform some comparison operation comparing to finite automata with the help of its stack memory. But Turing machine, you can see it can perform all the operation what the real world computer can perform. So it acts as a string acceptor, acts as a generating device, acts as the decider, acts as a transducer, means it can perform any operation, like any arithmetic and logic operations. So addition, multiplication, division, 2's complement, 1 complement, all the operations can be performed by Turing machine. And the last thing is the limit. Okay, so both left and right ends are bounded in the finite automata. You have only limited amount of string processing tape symbol, tape length. The same thing is mentioned in the stack push down automata also. Both left and right ends are bounded with stack. But in Turing machine, both left and right ends are not bounded. It doesn't have any limit, unlimited memory. Okay, you can have any number of inputs. And another one major difference that has to mention in Turing machine is, so you cannot perform erase operation in finite automata and push down automata. The erase operation can be performed in Turing machine. Okay, in Turing machine you can read the input, you can write the input, at the same time you can erase the input and you can rewrite the input. That is possible in Turing machine, which is not possible in finite automata and push down automata. Okay, so in the next session we will discuss about the definition of Turing machine and what are the elements available in Turing machine and what are the operations in Turing machine. So these contents are my own content. So this is I have written a textbook. So in the textbook these contents are made as a reference for this lecture. Thank you.